Hello and welcome to Algebra 2 CST release question number 42. It says this: two consecutive positive integers have the property that one integer times twice the other equals 612. What is the sum of these two integers? And so seeing that there are answer choices here, yes, you could kind of do a trial and error and see which one works, but with all these questions I'm trying to show you how to get the answer without just looking at the answer choices. Once in a while you can do that, look at the answer choices, plug stuff in or work things out based on what's there. But we want to be able to do these kinds of problems without the knowledge of what the answers might be. So let's figure this out the long way, I guess you could say. So two consecutive positive integers. The first one, let's call that x. So x be the first positive integer. And if you forgot what integers were, quick recap of that. Integers are just, I kind of think of it as the positive or negative whole numbers, or zero. Zero is also an integer. So if we go back forever, it keeps going back negatively, but -3, -4, -5, it keep going that way, -2, -1, up to 0, and then it starts going in the positive direction as well. And so it keeps going 4, 5, 6, and so on. So x is the first positive integer, so I'm actually, I'm actually considering just the numbers that are here on up. These ones aren't going to be positive integers. 0 is neither positive nor negative. So I'm considering these ones as possible answers. The next positive integer, though, would be x plus 1. Some of you might be tempted to say y initially, or just another variable, but we want to keep as few variables, or have as few variables as possible. That's going to allow us to solve for the value. So then x plus 1 would be the next positive integer. Why am I doing the next one? Because it says two consecutive, two that are right in a row. Adding 1 would be the next positive integer. Okay, from there, let's create a mathematical sentence, an equation here. So we have the property one integer times twice the other. So x times twice of the other one, 2x plus 1, 2 times the quantity x plus 1 is or equals 612. And so that's going to be the equation we need to use to solve for x. And so from here, I'm going to take this and distribute it through to that. Could I have said 2x times x plus 1? Would that have worked as well? Well, yes, because it's all multiplication. It doesn't matter really the order in which I multiply. I could do 2 times x plus 1, or I could do x times 2 times x plus 1. Either way will work. I'm going to go about it this way though. So I've got 2x, and I'm still multiplying this times everything. So I'm gonna go back on what I just said there. It's actually going to be easier to multiply 2 by x first of all. So just want to save myself some time. Mathematicians, I don't feel like we're lazy per se, but in a way we are, because we want to do things most efficiently. So we're just efficient. 2 times x, let's do that first. So 2x times the quantity x plus 1 would equal 612. From there we can distribute the 2x. I'd have 2x squared plus 2x equals 612. And from there I would subtract 612 from both sides. That would cancel out here and here. I'd have 2x squared plus 2x minus 612 equals 0. So we could try to factor this the way it is, but it's a lot easier if we actually divide everything by 2 first, because that's going to cancel that and that, here and here, and this I can change to 306 then. I can cut that in half, and so this will be easier to figure out. We could have also factored out a 2 of everything and then divided that by 2, but it does the same thing for us. And so I'd have x squared plus x minus 306 equals 0. And so from here, I'm trying to factor this out. I'm trying to figure out what two numbers will multiply to 306. I'm confident that it is factorable based on what I see over here, based on the fact that these are all real numbers. They're all not only real numbers, but they're all whole numbers. They're positive integers. So could I use the quadratic formula here? Yes, but I feel like I would be wasting my time. I don't really have to do that. So now I am going to utilize what's here just to make this less cumbersome. Basically, we're asking what are two numbers that will multiply to this number right here, negative 306, but add together to get positive. Remember, it's like there's an invisible 1 right there. So what's going to add together to get positive 1? So they have to be two numbers very close to each other, just one off from each other, which should make sense because that's what we had. We had one was one more than the other one. And so let's figure this out. Let's work this out. It looks like it's not going to be 35 because 35 would not go into 306. It's not going to be a factor. It would have to end in a 5 or a 0. Let's go with, I don't think 33 is going to work because 33 times 10, nope, that's not gonna be it. What could we have here? So I was thinking that one of these was going to be the values, but I gotta hold up a second. I was not reading this carefully enough. It says what is the sum of these integers, these two integers. So whatever I get, I have to add x and x plus 1 together to see what it is. And so let's try some values here. It looks like if I had 17 and 18, that would add to 35. 16 and 17 would be two integers that would add to 33. Let's try something there. Let's see if one of those goes into there. Let's go with 18 to start. I'm going to try that one and see what happens, see what I get. So 18 into 30, it's going to go one time. I'm left with 12. Carry down the 6. Does 18 go into 126? Yes, but how many times? I'm doing this without a calculator because I have to. I can't use a calculator on the CST. And for a lot of you, you won't be able to use a calculator on a final exam necessarily. But even if you can, we want to know how to be able to do this without a calculator. 7 times 10 would be 70. 7 times 8 would be 56. Putting those two things together gives me exactly what I'm looking for, 126. And so 17 and 18 are both factors then of 306. 18 times 17 would be that one of them has to be positive and one of them has to be negative to get a product of a negative 306. Which one is it? This one better be negative because I need to add them together to get a positive 1. And so our factors here that will work in this way would be x plus 18 and x minus 17. But solving this for x, this here is, remember, you can have one side or one factor equal to 0. It would make the whole thing 0. So that 0 product property, this one could be negative 18, and this one could be 17. That would make it 0. If I had negative 18 plus 18, this would become 0. 0 times, who cares what this is, would be 0. And then over here, if you had 17, 17 minus 17 is 0. And 0 times, doesn't matter what that is, would still be 0. So that makes that a true statement, both of those values. Now, though, we're using positive integers, so we can't use this as one of our answers. It's got to be 17. And so 17 is going to be x. It's going to be the first integer. So I can say x equals 17 and x plus 1 equals 18. But if we add those two things together, that and that are the two consecutive integers. The sum of those, the sum of these is 35. If we add them together, we get 35. And so good thing I reread the problem there. Sometimes that happens. Even as a math teacher, sometimes I gloss over something and then I have to look back at it again. But what's the sum of these? I had crossed out B before, but that is actually the correct answer. So number 42, choice B.